Hello everyone. Today we are going to continue on with various properties of quadrilaterals. Remember that our goal in this is to try to fill in as much information as we can, knowing only a very little about the figure. So let's think about rectangles for a second. Now, when you're looking at a rectangle, you know according to the definition that our corners are going to be at 90 degrees. We also know that this figure is a parallelogram. So see if you can remember what the qualities of a parallelogram are, and you might actually be able to fill in quite a few things. So pause for this for a second, see if you can fill in as many marks as you can. Alright, so here are the markings that you should have. You know in a parallelogram the opposite sides, of course, are parallel, so you should have marked in these. Also, since it's a parallelogram, opposite sides are going to be congruent. So you should have those marked in. Now we also know that with a parallelogram, opposite angles are going to be congruent, but since we already have those marked in as 90, you don't need to redo those markings. It doesn't hurt, but it doesn't really help us much because 90 is already more specific than that. And the other thing that you might have marked in is that the diagonals bisect each other. So man, we are getting a lot of marks on this. But it turns out there's one other piece of information that we can do, and that comes beyond the definition of a rectangle, beyond the definition of a parallelogram, and this goes into just a specific property of rectangles. The diagonals are going to be congruent. Now we already have a lot of congruency markings on here, so we're just going to write a statement. What this is saying is not that these two pieces are congruent, it's saying that the entirety of AC will be congruent to the entirety of BD. And that actually is going to be enough information to always identify a rectangle. We're going to see that later on. As soon as you see that the whole diagonal is congruent to the whole other diagonal, you could actually say this has to be a rectangle. In fact, because the whole things are congruent, it actually means that this little piece will be congruent to this, which will be congruent to this, which will be congruent to this, because they're split into all equal pieces. So that's another way that you can tell if all of the pieces of the diagonal are congruent to each other. It has to be a rectangle. Now let's use this. So in the rectangle above, if AC is equal to 5x plus 2 and DB is equal to 7x minus 6, find BE. I want you to try this first by yourself, and then I'm going to give you the answer and do a quick walkthrough that you can skip if you get the answer right. Now what you guys should have gotten is that BE is equal to 11. If you got that, go ahead and skip right till when you see special properties of a rhombi at top. If you didn't, let's quick check out how this works. Since AC is a diagonal and DB is a diagonal and it's a rectangle, always watch the figure names, that means that these two things have to be congruent to each other. So I'm going to set them equal to each other because we know that if two things are congruent, then their measures are equal. Now I can solve to figure out what x is, and this is going to allow me to find the overall length. So here I can add 6 to both sides to get 8, and I can subtract 5x from both sides to get 2x. Dividing both sides by 2 is going to give me x is equal to 4. Since x equals 4, or 4 equals x, I can put it into either one of the diagonals to find the overall measure. I'm going to use AC simply because multiplying by 5 is really easy. So AC is going to be 5 times the answer that we just found, 4, plus 2. Therefore, AC is equal to 22. Now, I figured out what AC is, and I do know that that's the same then as DB. And if I want to find BE, what I really want to find is half of my diagonal, because remember that since it's a parallelogram, the diagonal is bisected by the other diagonal. It's split into two equal pieces. So in order to find BE, I just divide the overall diagonal by 2, giving me 11 is equal to BE. And don't forget that this also means that all of the other diagonals are also 11 in length. What about a rhombus, or the plural, rhombi? Well, in these ones, we're going to have slightly different rules. Now, we already know that in a rhombi, rhombi, all sides are going to be congruent. So I could mark in all of these sides as congruent. I also know that it's a parallelogram. So just like before, I can add in several markings there, and go ahead and try that out first on your own. Here are the markings that you should have. Opposite sides are parallel, and you should also have the opposite angles are congruent. And you should have that your diagonals bisect each other. Now notice here you can physically see that these diagonals are not equal in length, and that makes sense. This is not a rectangle here, so this diagonal is in fact shorter than the other diagonals. So it's only the pieces that end up being congruent to each other when they're bisected, not the overall diagonals congruent to each other. And keep in mind that these two diagonal pieces will have different lengths. Now we do have two new pieces of information though. In a rhombi, each diagonal will bisect the two opposite angles. Now, this gives us information about our actual angles, and what it's saying is that this is going to be equal to this. And that's because the diagonal's cutting it through the center exactly. It's cutting that angle through exactly. And on the other side, the same thing's going to happen. In fact, these are going to be the same length to each other, because if the overall angle is equal and you split them both exactly down the middle, then the two pieces would have to be equal to each other. You also have the same thing with the larger angle here at A and at C. It's bisecting that as well, so that these are going to be two equal pieces. Now, if that wasn't enough information, you're also told the diagonals are going to be perpendicular. So this is really a perpendicular bisector. And that gives us then quite a bit of information, because now we have tons of information on all of the angles. And you're going to be able to find pretty much every angle of a rhombi given only one. In fact, to see if you can do that, go ahead and try out this first problem here. I will show you guys the answers in just a moment. Go. Here are all of those angles. Now, if you're like, oh, what? That's not what I got. Don't worry. I'll walk through exactly how you can do this. So first off, you know that it's a rhombus. And that's key, because you cannot make any conclusions until you know what sort of shape that you are what sort of shape you're dealing with. And what we're going to do then is, I'm only focusing on the angles, so I'm not going to add a billion marks, because all these marks can get a little bit confusing and overwhelming if you see them all at once. So let's just start with what it tells us immediately. Angle DBC is 34 degrees. Okay, so the thing that it first asked me is, what is the measure of BEA? Well, I know this is a rhombus, and if it's a rhombus, I know that the two diagonals are perpendicular bisectors. So that means it has to be 90 degrees, and I don't really have to do any math. I just know that from the rules of a rhombus. For B, it asks, what about ABE? So this angle right here. Well, this angle right here, I know has to be congruent to angle DBC, that 34 degrees, and that's because the diagonals are angle bisectors. So I know that that's 34. Well, that's all well and good, but then it asks, well, what about measure of angle ADC? Well, that's this angle across over here. Don't forget that this rhombus is also a parallelogram, because rhombi are always parallelograms. Man, I'm struggling with that today. Sorry about that, guys. So that means that the full angle D will be equal to the full angle B. And since B has two pieces, 34 and 34, I can find the overall measure of B by just adding those together to get 68 degrees, which means the opposite angle, D, will also be 68 degrees. That brings us to BDC. Well, BDC is going to be just half of that, which is 34. In fact, I could even just fill in this if you wanted. Well, that brings us to E. What about the measure of angle DAB, this angle right here? Well, don't forget that this is a parallelogram, and consecutive sides are going to be supplementary. That means that 68 angle D plus measure of angle A will be equal to 180 degrees. By the way, you can also find this using the properties of a quadrilateral if you forgot that these two angles are supplementary. You can even also find it using the properties of a triangle, since you know that this is a 90-degree angle and you know that this is 34 degrees. So there are lots of ways to solve for this angle, but this is probably the simplest. When you subtract 68 from both sides, you end up with measure of angle A is equal to 112 degrees. Which leaves us to our final one. What about DAC? Well, that is this half angle right here. And because the diagonals of a rhombus bisect the angle, that means it's just half of 112, which is 56. That leaves us with only this. We want to find each measure in rhombus MNOP. And we're actually going to simplify this a bit. I just want to know what is X and what is Y. So how can we find that? Well, let's start with just the general information given to us. I know that QP is y minus 2, and I know that QN is 2. That means that since this is a diagonal, it's bisected, and those two pieces will be equal to each other. Therefore, that gives me y is equal to 3. Now, once I know that, of course, I can write in a few other measures, because I know that this is y plus 1, so I'd have 3 plus 1. This would be a 4, that would be a 4, and I could fill in those as well. Next thing that I want to find is, let's figure out, though, what X is. Now, this one might take a few more pieces of information. Don't forget that we are looking at a rhombus, and so this has to be a 90-degree angle. And there are, mind you, a couple ways to solve for this. I'm just going to use this one. Now look at the sort of shape that we have. You should always be looking for shapes in geometry, even if it's not the shape that was originally given to you. This is a triangle, and currently what we have are 3 angles in that triangle. We have a 7x, a 3x, and a 90 degrees. Well, I know that the sum of the angles in a triangle is equal to 180 degrees. So I can solve for x. This gives me 10x plus 90 is equal to 180 degrees, which means 10x equals 90. Subtracting 90 from both sides, and when I divide both sides by 10, I end up with x is equal to 9. So if x equals 9, I can find each of these angles, and going forward from that, it means I can find the overall M, N, O, and P angles. And that gives me really tons of information. I can also find the overall angle or overall length of MO and PN simply by taking the sum of these. And if you guys remember the Pythagorean theorem, you can even find the lengths of each of these sides. But we don't need to do that today. In fact, for today, you are completely done. All I want you to do is take a picture of the notes that you did, whether they were on this page or a different one, just to confirm for me that you did watch the video and you have all the information that you need. That is everything for today. I hope you guys have a good day.